Today we're graphing linear inequalities. You've graphed inequalities before, but only in one variable, like x is greater than or equal to 5. Since we had greater than or equal to, 5 itself was included as part of our solution, so we put a solid dot at 5 and shaded to the right for all the values that are greater than 5. When we graphed x is less than -3, -3 can't be less than itself, so we put an open dot at 3 showing that it was not part of our solution, and then shaded to the left where we can find all values less than -3. Well, now we're going to move on to graphing inequalities in two variables, like y is greater than 2x minus 4. Notice how much that looks like the equation y equals 2x minus 4, which happens to be in slope-intercept form. Graphing that line as if there were an equal sign there is always where you start when graphing inequalities in two variables. So let's take a look. Graphing the line y equals 2x minus 4 tells me to start on the y-axis at -4 and then use our slope of 2 to graph our line. Now, because this is the first time we've done this, we're going to do some investigation. First of all, we need to understand what it is we're looking for when we graph inequalities. We are looking for all points, and I mean all points, that can be solutions to our inequality. Remember, in order to be a solution, the points must have a pair of values, an x value and a y value, that make the inequality true when we substitute those x and y values into our inequality. There's always more than one solution to an inequality, so we're going to take the time for just a minute to investigate which ones will work. In order to find which points are part of our solution, we're going to check three different places. We're going to check the area above the line, we're going to check the area below the line, and then we're going to test points on the line itself. Let's start with above the line, and when I say above the line, I'm talking about this area here. I could also have said to the left of the line. I just need a general area. And I'm going to pick a random point in that area. For today, I picked the point 1, 2. 1 for x, 2 for y. I substitute those values back into my original inequality. And then, of course, I need to simplify the right-hand side. 2 times 1 is 2, minus 4 gives us -2. My inequality says 2 is greater than -2. Is that true or false? Well, this is a true statement. That point is definitely part of our solution. Well, turns out if one point in that area is part of our solution, then every point in that area is going to be part of our solution. Keep that in mind as we test our next point. Now I'm going to randomly pick a point below the line, or in this area. And I'm going to pick the point 5, -1. Using 5 for x and -1 for y, I'm substituting them back into my original inequality. 2 times 5 is 10, minus 4 is 6. That gives me the inequality -1 is greater than 6. True or false? Definitely false on this one. That means the point I picked is not part of our solution. And in saying that, that means that any point in that particular area will not be part of our solution. And lastly, we need to look at a point on the line itself. I'm going to pick the point 3, 2. Again, substituting those values into my inequality and simplifying, I get 2 is greater than 2. True or false? This is definitely false. 2 cannot be greater than itself. Just throwing it out there though, if that had been greater than or equal to 2, we would have said yes. So now let's take a look at what actually happened here. When you graph inequalities, and I'm going to start with on the line itself. When the points on my line are actually part of our solution, I would draw that as a solid line, just like we had a closed dot before. If the points on the line are not included in our solution, like a point on the line was a no for us here, we draw the line as a dashed line to indicate that that's equivalent to an open dot. Nothing on the line itself is part of our solution. So if you have greater than or equal to or less than or equal to, we would draw a solid line. But if you have just greater than or just less than, we're going to draw our line as dashed. Then we have to consider the area that holds our solutions. Remember, the points in this area were not part of our solution, but the points on the other side were. Since there's an infinite number of points on that half of my graph, I can't take the time to list each and every point. So just like we shaded on our number lines to show all the values that were greater than 5, we're going to shade an entire half of our graph to show which half of the graph holds our solutions. Now, since you don't have a computer to shade that entire half of your graph, a lot of students will just simply take their pencil and after they draw the line, just put some scribbles on that side to show which side they're talking about. Just don't feel like you have to do a perfect amount of shading. Now, this was y is greater than 2x minus 4. Let's look at what happens if we reverse our inequality and make this less than 2x minus 4. We're going to keep our line, and again, this is just less than, so we have a dashed line with a y-intercept at -4 and a slope of 2. And now we're going to pick a test point. I'm going to pick the point 4, -3. This is in the section of graph that was not part of our solution before. Plugging those values into my original inequality and simplifying, I get -3 is less than 4. True or false? Well, this time, a point on that side is actually part of our solution. And again, if one point in that area is part of our solution, then you'll find that all points in that area are part of our solution. So that's the half of the graph that we're going to shade this time. Now, notice I did not this time pick a point on the other side of the graph or on the line itself. I only ever need to check one test point. That's going to tell me instantly which half to shade. If it makes my inequality true, that's the side of the graph I'm going to shade on. If that happened to make my inequality false, I would have shaded on the opposite side of the line. Let's reiterate what's happening here. First of all, we graph the line itself. If you have points on the line that are included in your solution, in other words, if you have less than or equal to or greater than or equal to, you graph that line as a solid line. If the points on your line are not included as part of your solution, if you have just less than or just greater than, you're going to draw that line dashed. Don't forget the arrows on both ends though to indicate it goes on forever. After you graph the line itself, you pick one test point, not on the line, substitute the x value and y value from that point into your inequality, and see if it makes your inequality true or false. If it's true, that's the side of the line you want to shade. If it's false, we're going to shade on the opposite side. Let's do one more. This time, let me move that out of our way. This time we have an inequality that's in standard form. The x and the y are on the same side. This is not slope-intercept form this time. Remember, to graph in standard form, we use the x and y intercepts. To find the x-intercept, y has to be 0. If I look at this and pretend like that was an equal sign, I would get x equals 4. And that's my x-intercept. To find the y-intercept, x has to be 0. Solving that as if it were an equation, I would get y is -3. And that's our intercept. Using those two intercepts, I can graph our line, and because this is less than or equal to, that's going to be a solid line instead of dashed. Now we pick a test point. In this case, I'm going to pick the point 2, 3. Substitute that x value and y value into our original inequality. Simplify. 3 times 2 is 6. 4 times 3 is 12. And when we do that subtraction, I get -6 is less than or equal to 12. True or false? In this case, that's a true statement. -6 is less than +12. So that's the side of the graph I'm going to shade. Again, if that had been false, I would have shaded on the opposite side of my line. Alright, I think that's enough about graphing inequalities today. I hope the rest of your day goes well, and I'll see you next time.